Alright, 11.8 is modeling data with polynomials. And what we're going to do is we're going to find the equation now for those polynomials. So the first thing, remember, is that you go and you subtract them to find out what degree they are. So you literally go and you say 2 minus your 1. That gives me a 1. 4 minus 2 is 2. 7 minus 4 is 3.
4, 5.
And then we have here, this is 4, and then 5. That would be, if it was a first degree, all of these would be the same number, but it's not, so it's not a first degree. Then you would subtract them again. 2 and 1 is 1. 1, 4, 3 is 1. 5 minus 4 is 1. So we can see that it is clearly a second degree polynomial. Alright. If we have a second degree polynomial, what does that mean? Hopefully you all agree that we would have something that looks like y equals ax squared plus bx plus c. Because that is a second degree polynomial in general form. Anybody not agree that that's what it is? Alright, so now we want to look and solve for a, b, and c. So if you want to solve for 3 variables, a, b, and c, what you have to do is you have to create 3 systems. You have to create a sentence. You have to create 3 sentences with your system. So what you're going to do is you're literally going to take your x and y value and create a problem. So you're plugging in your 1 for your x and your 1 for your y. So what does y equal? 1. And so does x at this time, just coincidence. It will not always be that way, but it does on this one. So we have 1 squared plus b times 1 plus my c. I want you now to take your second number, 2 for your x and 2 for your y, and create another sentence. Hopefully you guys put 2 for my y, and then I have a times 2 squared plus b times 2 plus my c. How many did I say we have to have when we have 3 variables? 3. So that means you have to take another point, right? So we're going to take our 3 for our x, and at this point, what is our y? 4. And you're going to put 4 for your y. And I want you to create another sentence. So hopefully you have 4 is equal to a times your 3 squared plus b times 3 plus c. Anybody not have that? Alright, let's clean up our system. So remember, this is my system we're going to be solving for. So we have here. Now, will it bother you guys if I put the equals on the other side? So it'll be easier for your problem later? Okay, so I'm going to put this on here. So my first one is a plus b plus c equals 1. Two squared is 4, so I have 4a plus 2b plus c. And that equals 2. 3 squared is 9, so I have 9a plus 3b plus c is equal to 4. Question about yet? If you have a graphing calculator, you will like solving this system. If you don't have a graphing calculator, you probably won't like solving this system, but I'm going to do both ways. So if you have a graphing calculator, what you get to do is you get to put them in matrices. Does anybody remember what you have to put in your matrix? What do you put in for your Remember, you put your coefficients, so you're putting in 1, 1, 1. What's my next line? 4, 2, 1. What's my last line? 9, 3, 1. Do you remember what has to go up here? The inverse. And then you multiply it by the answers, and that's why I moved the answers over so we can see where they have. So it's 1, 2, and 4. So I want you to put that into your graphing calculator. It's red, but you want a pen?
Oh, sure.
Alright, did you guys get it? So remember that you are solving A, B, and C. That's what this is going to equal. So A, B, C equals, did you get 0.5, negative 0.5, and 1? Anybody not get that needs help finding that? Okay. So your final step is to write the general equation using A, B, and C. So we have y equals, instead of A now, you have 0.5 x squared plus B, but B was negative 0.5, so negative 0.5 x plus my C, which is 1. Alright. If you got it and you have a graphing calculator and this is the way you want to do it, you may start on your homework or you may follow me. You may follow me on the linear combination, but I will tell you that the linear combination, if you do not have a graphing calculator, is a long process. But I am going to walk it through, so you will have to stay quiet while I am doing the linear combination. All right. All right, first of all, anybody not have this page? All right, so what you have to do is, if you don't have a graphing calculator, I'm going to rewrite the system, which is A plus B plus C is equal to 1. And then you had 4A plus 2B plus C is equal to 2. And 9A plus 3B plus C was equal to 4. So what you have to do is you literally have to take two of them and get rid of a variable. So I'm going to take these two and get rid of C. So my first step was, I'm going to put this on the top because it's bigger. So we have 4A plus 2B plus C is equal to 2, and then A plus B plus C is equal to 1. So I have to find a way to get rid of my C's. So I have to multiply through by a negative number. So I'm going to go through and multiply everything by a negative, and then I'm going to add down. 4A minus A gives me 3A. 2B minus B gives me B. This cancels out, giving me a 1. Then I have to do it the same thing with my bottom one. So my second one time through, and I'm going to grab the top one because that looks easier. You have to have two of them. So I'm going to go 9a plus 3b plus c is equal to 4. And a plus b plus c is equal to 1. Again, I want one of them to drop out. So what can I do?
Make all the bottom negative.
Make all the bottom negative. So I'm going to make the bottom negative. So I have 8a plus 2b. This drops out. I have 4 minus my 1 gives me a 3. Then I have to take these two equations and get rid of a or b. So my third step is to take this equation and this equation and get rid of a or b. So if I have 3a plus b is equal to 1, 8a plus 2b is equal to 3, I want to get rid of a or b. So what can I multiply top or bottom by to get rid of?
Top by 2.
Top by negative 2, right? So I'm going to top by negative 2. So I have negative 2 times 3 is my 6a, negative 6a minus 2b is equal to a negative 2. Bringing this down, 8a plus 2b is equal to 3. Almost done. I cancel that out, so I have 8a minus 6a is 2a is equal to 3 minus 2, 1. Divide by my 2, so a is 1/2, which is what we got when we did the matrices. Then I have to find out what b is, so I have to put a into this one. So I have 8 times my 1/2 plus 2b is equal to 3, so I have 4 plus 2b is equal to 3. Subtract the 4, so I have 2b is equal to negative 1, divide by 2, so b is equal to a negative 1/2. And so you can clearly see that b was what we got, negative 1/2. And then to find out what c is, you have to take it to one of the top ones. So I'm going to just take it to that top. So it says a, so 1/2, plus b, so plus a negative 1/2, which is already 0, plus c is equal to 1. So c clearly is 1. Wait, sorry, what? Sorry. Did you see a? Oops, I missed my a. See if I can shrink it down. That helped. So I took that top one and I took 1/2, negative 1/2, and then c. Yep, so I got c. So then my last step is just clearly to do my y. Remember, y equals a, which is 1/2, x squared, plus b, so negative 1/2 x, plus c, which is 1. And that's your linear combination. And when I was in school, I didn't have a graphing calculator, so we couldn't do matrices. So every single problem, this is how we solved it. So just so you know, because if you don't have your graphing calculators, you really can't do your 3-system matrices. All right. Questions? Again, what I want to tell you guys